Yeah, if the note sheet, if the sign-in sheet can keep going around, just to. Great. So I'm David Chudzicki from Kaggle, not Ben Hamner. He couldn't be here. So this is Christine. Christine and I are giving this tutorial. Christine is from Continuum Analytics. We also have some other people. So we're both data scientists. It's a pretty broad term, but I've learned to adopt the broadness. There's a few people around the room who aren't speaking but can help out. Wow, I feel really weird with a mic in a room this size. There's a few people around the room who can help. Matt Rocklin in the back, can you wave, Matt? Is also from Continuum. And with the bright green shirt, Walter Reed here is in the Kaggle community. He's done well in a number of competitions, and so he can kind of help people work through learn things and work through problems and so on. With that.
Hi, good morning. So we want to make this tutorial more of a competition, a real Kaggle competition, so you feel what it is to work on it. And so, and we're going to have prizes at the end. We're going to have a leaderboard. We're going to have some winners. And so it's more of a competition. And you can work on your own, on teams, to solve the problem. So it's really, we want to make it really hands-on and talk when we need to talk, give like some hints, some tricks, but most of all, let you work and find how good your models are and help you out in improving them. So that's how we're going to structure. Sometimes we're going to talk for some like 20 minutes or something like that, and then let you time to apply those models, improve them, and see what you can do and come up, right? And if anyone is welcome to, like, if they find a really cool feature in the data set, or if they get a very good performance and want to come up here and present what they found, we're also welcome that you do that.
Great, so I'm going to talk a little bit about Kaggle competitions in general. Maybe just to get to know the audience a little bit. How many have participated in a Kaggle competition before? So a few of you. And then just we'll use Scikit-Learn, and I'm curious how many were at the Scikit-Learn tutorials yesterday, or have you used Scikit-Learn before otherwise? Great. So the sign-up sheet done. Great. So I guess some of the things you'll learn in this tutorial, I think, are starting to move towards a nice workflow for data science. Not kind of trying not to get caught up in what do I do now and where's the data and how do I get things running. Sort of learning to explore data, learning to iterate quickly by kind of refactoring the code we use into reusable pieces that you can keep things kind of clean and tidy and not get lost in all this code. We'll test our models by submitting to Kaggle, but then we'll also test them by making our own train test splits locally, which is another, I think the theme here is going to be trying to iterate quickly. That's maybe the biggest thing that makes a difference in doing well in these things. So if we can test our models out locally before we submit them to Kaggle, we can avoid overfitting, which we'll talk about, but also just have a quicker iteration process. Then we'll sort of think about how to create features to use in our models. And toward the end, Christine will talk about optimizing parameters that are in your models. So if you want while you're talking, or if you haven't yet, you can sign up for a Kaggle account, clone this PyCon 2015 Kaggle tutorial repository, and then, sorry, this should say the input folder. Put the data in the input folder. So just a little bit of an intro to Kaggle. We have these data science machine learning competitions. People from all around the world participate. So um, we just to go through examples. One of my favorite competitions was this essay scoring competition that we ran. So it's using, or another one, kind of predicting toxicity from molecular structure for this pharmaceutical company, Boehringer Ingelheim. So how do these competitions work? There's some data set. In this toy example here is a data set of home prices with kind of features about the homes and then what the sale price was. So there's always some kind of target variable we're predicting. And then the data is always split into train and test. So that there's a ground truth about the test set, but we don't tell that to you. Those are, you get the truth about the training set, but you don't get the truth about the test set. You have to make predictions about that. Then you make these predictions. We have the truth about the test set, so we can compare, look at the difference between the predicted and the actual, and give you a score. So one twist here is that the test set is the idea of overfitting. That if you just, it's possible to have a good score on one set in a way that doesn't generalize to another set of new data, right? So we divide the test set into what we call the public and private leaderboard, where during the competition you see your results on this public leaderboard, but then the private leaderboard is not revealed until the end, and that's what we use to determine the winners. So when you submit, you'll see your score, see where you are in the competition. And then often what happens is the performance, and I think we'll see this in our competition today, performance improves throughout the competition, but eventually sort of leveling out. And so we think of that as the frontier. And in most cases, we think competitions are kind of getting to the best performance that's possible on this data set when in a larger competition with a number of people. So that's what sort of this frontier indicates. In a short amount of time, we might not see that leveling off in this competition. We might see continual improvement, and it might look like we're going to keep improving if we work a little more. And then, kind of as I was saying, that different competitions can have a different characteristic, but most of the time they get this sort of leveling off in performance. Great, actually. So I think that's, there's some other, I might talk with some other slides later about kind of things that Kaggle competitions are good for or not good for. But right now what I want to do probably is just launch into getting started working. So I was just going to get started in a little notebook that I'll write here for you, and then set you loose to work for a little while on your own with help from us. I'm wondering how many people have their environment set up well, like that you're happy with. All right. Who doesn't? Yeah. Wave if you don't. And then Christine can find you. And all right, so I think we'll get started. And then when you start working on your own for a little while, people who don't have their environment set up should be pretty quick to happen, especially with help from Christine or Matt. Sort of any, I guess also any questions about kind of what's going to happen here? We're going to go through a few little sessions of demoing some ideas and then letting you work on your own for a while. And then, as Christine said, maybe people can present things they come up with. Sounds good? Great. So, whoa, sorry about that. Yeah. Is it too loud when I speak? Okay. So this, Christine was telling you a little bit about we're going to have a competition here. The data set you might have seen is based on Stack Overflow questions. And the target variable we're predicting is whether the question was closed, as a kind of, if questions are inappropriate, they can be closed for a number of reasons. So the not really a question, things like that. So the target variable we're going to predict is whether the question is closed or not. Probably one of the first things we'll do is read a CSV file, which pandas is good for. How many of you use pandas? So that'll be new to some of you. Let's see, just to I think probably most people have used iPython notebooks before too. Is that? But if not, then it's pretty explanatory. You can sort of shell out to the shell with this exclamation point. Which all right, so we're just to get oriented. Where are we? We're down in this one live folder. Each of these little sessions, what we're planning, if you want to look ahead or use the content we're planning to come up with in your work, you can look at these folders 1, 2, and 3, which kind of show where we're going. So if we read a CSV file, see it. Then we can use the pandas head function to see the top of that CSV file. So we have a post ID, post creation date, the user ID for the post owner, reputation. We get some text here. The title of the post, the body of the post, some tags, and then this last column is our target variable, whether the post is open or not. And then one thing I like to do sometimes is transpose things in pandas. That's an error because I called the head function without actually evaluating it. I didn't call the function. Then we can kind of read down the rows instead, and maybe that's a more compact way to see kind of what columns are here. So one thing that we do in Kaggle competitions is creating features, right? So we look at these what's in our data set already and say what features can I create from that might be helpful. So in this case, if we create a title length feature by applying the length function across the title, then we have title length in our data frame. So typical title lengths look like they're under 100, a few above 100. Then another theme here will be visualization. So I'm going to import some visualization libraries that I like. Matplotlib. Seaborn is mostly a bunch of helper functions that kind of make Matplotlib experience nicer if you haven't seen that before. NumPy, and then this thing that gets our Matplotlib plots to appear in line in the notebook. So then if we make a histogram of this new feature we've created, we can see sort of how it's distributed. And then one way to think about whether it's whether this is a helpful feature will be to make different histograms for the two classes we're interested in. So there's the closed questions and the questions that are still open. So if we make a histogram we can feed into Matplotlib kind of two series of values with two different labels. Get a plot. Maybe if we add a legend to the plot, we can see that questions are more likely to be closed if they have a very short title, which makes sense. Then let's. So we could do the same thing for this reputation feature, where, sorry, following the same approach, we make a histogram, but it's hard to see what's going on in this histogram, right? The data is very, very skewed. So maybe if we zoom in on the lower reputation users, we can see, I was surprised to see there's some even negative reputation, but that's possible if your question gets downvoted enough. Then at the very low end of, say, 0 reputation, posts are more likely to be closed. Our open status column means 0 if it's open, has 0 if it's open, and 1 if it's still closed. So more likely to be closed if the asker has low reputation. So now we want to, let's get, what we want to do at this point is start creating a model. So to submit to our Kaggle competition. So what we can do is, you'll notice we've done some work to create a feature, right? Where what do we do? We said title length is, we did this operation on the title to get the title length, but we only applied that to the training set. So we're going to want to apply the same operations to the train and test set, so that we can have the same features available when we make predictions as when we're training the model. So if we start let's see. One thing we can do is refactor that into a little function that, I'll make that bigger, that reads the data and then creates a title length feature and then returns the new data frame. So then we can apply that to the test set or to the train set. So that's what'll let us so if I run that bit of code that we refactored into to make that function available, and our train set is already what we want it to be, but just to make sure we're being consistent, I want to create the train set feature matrix by running that load feature matrix function that we wrote. But something's wrong. Public leaderboard would be, I think that's the test set for the public leaderboard. Yeah, so I just wasn't sourcing the right file. So I've organized these Python files into 1, 2, and 3. The train. Let's get a test set too. And then maybe we'll start with a logistic regression model. So from Scikit-Learn, we can import logistic regression. And then we've looked at 2 columns so far. So let's, maybe the columns we want to use are reputation and title length. So it's nice to say, kind of create a variable for this. Then if we decide to change it later, we can iterate quickly. And let's fit our logistic regression. So the way this works is we need to feed, it's a little bit awkward, we have to feed an array to Scikit-Learn instead of Pandas data frame. It's not this, there's no native interoperability. We have to do this conversion between different types ourselves. And we'll tell Scikit-Learn what the features are, what the target variable is, and then we get a model. So if we can use this method on once we've fitted the model, which we can use this predict method to make predictions. So we have these predictions, which are ones and zeros for closed or not closed, and then just to get a kind of start to get a sense for how accurate the model is. This actually won't be the metric that's used in the competition to score, but as a metric that kind of makes more sense intuitively, we can just look at how often does the prediction agree with the actual answer, which is we're doing a little bit better than chance here. And so now if let's see what the predictions ought to look like. So there's a sample submission. It can often be hard to to figure out sort of how should my submission be formatted without sort of seeing an example. So it looks like we have a submission should have an ID and an open status. And rather than submitting ones and zeros, we should submit probabilities. So we can get probabilities with another predict method, predict probabilities. And then that'll give us two columns, one for the probability of being in the class and the other for the probability of not being in the class, which we just want to submit one probability, the probability of being open still. So that's what we'll get the second column there. We've seen what a submission should look like. So we want an ID and an open status. So if we make a pandas data frame with an ID and an open status, which is our predictions, and make a submissions directory, which already exists for me, so we don't need to do that. But if you do, then write our submissions to a file. And then what do our submissions look like? We've got this index. So the pandas writes this index that it uses by default, which can be useful. The index is how you join things, but we don't want that in our submission. So instead, we'll write to CSV with index equals false. Looking at what that looks like. So we have open status ID, which is what we want. And then we can actually go submit that to Kaggle. So I'll make our first submission here. We can drag or click to make a submission. And then we have a score here. I'm excited to be in first place. Maybe I won't tweet it right now. But and then so we've got a score. So what is this score? That's something to kind of always think about in a Kaggle competition. The score in this case is something called log loss, which is the way I think about it is it's based on so it's based on the probability that the probability you submit. And so the way what's a natural way to judge how good is that probability? What we want to do is penalize you for probability. Like if you have a high probability on something that's wrong, we want to penalize you, right? So if we look at one of your submissions, one of the rows you submit, and say, what's the probability of the right answer given the probability you submitted? So if we believe your probability was, if you say 0.7, and it's really 1, then there's a 0.7 is the probability of the true answer given what you said. If it was a 0, then then the probability of that was only 0.3 given the 0.7 that you submitted. So the way I think of it is kind of multiply all those together. Each of those is a penalty. The penalty might be 1, which is no penalty, if you're exactly right. And then the further off you are, the smaller the number we get when we multiply those together is. But then just to think of it like an accuracy, it's the negative log of what I just said. So I realized that was all that probably went by a little fast. But the things to know are there's a big penalty for being confident but wrong, which is appropriate. And then just like a measure of accuracy, lower is better. So my submission here, this 0.68 is slightly lower than if we gave even odds to everything. And I guess just as an aside, it's not that even odds is sort of if you're just going to make a submission, a constant submission, even odds is the right one to make for this data set. And that's not because half of the questions on Stack Overflow are closed. There's a stratified sample here where they sampled the data in a way that got half closed, half open, which is a nice thing to do when you're building a model. Is most questions aren't closed, but you're going to build a better model if you use more efficiently build a better model if you use kind of 50 closer to even distribution. So I think we've been helping people get set up with their environment. I think the thing I want to do now is if you want to form little groups or just work on your own for a little bit. What are some things we could do next? So we could explore some more features. So what else is in this data set? How can we use that? Maybe see with charts or other charts, like what in it kind of any way you prefer. See how good the other features in this data set are for making predictions. Do they look like they're related to the right answer? After visualizing a bit, maybe make your own submission with some more features. Maybe a different Scikit-Learn model if you want. And really, just those are just some ideas. But whatever. I think if you try to work towards making one of your own submissions in this first, maybe we'll take 20 or 30 minutes to sort of work a bit with Christine and me and Matt and Walter, kind of walking around, helping out.
Hello? No? Yes. Okay. Okay, we have 16 submissions. Who hasn't submitted? There's someone who has not submitted. Raise your hand if you have not made a submission. Come on, what are you waiting for? You can just like submit the first one that we got, the 068. Everyone's around 068. There's not gonna be a blame on you. So go ahead and try to submit. We wanna see more teams up here. We just mark him. Who's that? Who's number one? Good, good. Um, in this second section, what I wanted to go through is kind of how you optimize your time. And instead of just like making a model and submitting and seeing what your score is and iterating over that, is how can you test that locally before you make that submission, and how you test your models locally before you get that score. And as we've seen, usually in machine learning models, you split your training data in between training and testing. And that has done for you the train and the test, but the test you don't have the answers, right? So that's what Kaggle is hiding from you. So we could replicate that split in the training set that we have, where we have the actual true labels. And then we can locally get what our score might be in the test data that Kaggle has to compute the leaderboard in a way that then we can decide what model we upload. So there's a cost to that. The cost to that is that you're losing some training data that you're using to compute your end result, right? And we know that the more data you have, that loss of data can also be a loss of accuracy. But at the same time, we're trying to generalize. So by doing that split early on, you can reassure yourself that you might not be overfitting. So we have a simple notebook here that tries to show you how you could do that. And in your train set, which is the one we have all the labels for, we can use this train test split in Scikit-Learn cross-validation right here, and decide to like split this training set that we've got with all the labels into two parts, training and testing. My train, my test, and see what percentage of the test of this data set that we have, we wanted to make it a test. That test is gonna be used to evaluate the model. So that way the training part of this, what we call my train, is the one that's gonna be used to like fit the model. And my test is gonna be used to evaluate how good that model is. So let's have a simple example. Let's imagine we wanna fit logistic regression, and we want to fit the model just using the title length, very simple one. It's going to be very bad one, but just to demonstrate this. And then we want to fit the predictions and compute the log loss, right? We can put all this process into one single function called getScore, and we say, okay, this is going to be my train part, the testing part, what model I'm going to use, and maybe what columns of my data set I'm going to use. Bigger? Better? Yeah. So that way we have this function getScore, and we can pass models with different parameters, and compare ourselves how good we are doing, right? And then the best model that we get, that's the one we're gonna make the submission in the website. I don't know if you're familiar with the concept of random forest and bagging, but it's become a very popular models because it's known that single models are sometimes biased, and they might not properly represent all the intrinsic representation of what's happening in your underground real truth data. And then by having a model like random forest, which is like a combination of multiple models, and having a system where all these models vote, and you get not like one not one model says, but what like the most agreed um, uh, label is, which can be done in many different ways. That is been demonstrated in a lot of the Kaggle competition, that these types of models actually perform better. And this is a very simple example of a random forest classifier, and you have to pass, which is uses different decision trees, and you can pass different parameters, and then we can show how we can use this like function we've created of using your train, your test, the model you want to use, and like what kind of what columns of your data set you want to use, and you get the score. And you can iterate with this small function over and over, and finding different models with different parameters and seeing what your score is, and then finally making the summation of the best you found. Then I wanted to go over like why is it important to have a sense of how well your model is generalizing. Imagine we don't do this split. For example, this just random forest we just like computed. If I just perform it on my training, right? If I just test it on my training, I get a very good result. But that means that model, it's really just getting the insights from that particular data set, and it's not generalizing well enough. And how do I know that? Because I have split my train set into train and test, and I see when I apply it to the test, actually the performance is pretty bad, right? So again, we have to be conscious that we're having a loss, right? We're using less data to train our models, so there's a loss there. But then we're assuring ourselves, we're not lying to ourselves, we're not saying that our model is very good when it isn't. So this notebook just tries to, you can use this get score and try and testing different models. You can use models from Scikit-Learn, Logistic regression. You can find a list of all the possible, and read on Scikit-Learn like what parameters can you pass and things like that. And then just use this get score and find like what's the best you can do, and submit this new score to Kaggle and see how we all are rearranged in the leaderboard. Does that sound like a good idea? That's available in like the notebook number 2. You can just like copy it and just like change the model, change the columns, change maybe the all the different variables that we have, the test size, different parameters inside of the different models, and try and see like what's your score.
Some more time to work on your own models a bit. I wanted to kind of show one more feature that we have off before you get started. So there's this there's this thing called Kaggle scripts, which is a neat way to share kind of code or visualizations. You can kind of type your Python into this box, more likely copy paste. It's not a great interactive environment. And then the results can show up either in the log or in the output files and images. So if you want to kind of show someone a nice visualization and along with the code that made it, that can be a good way to share that. So if you, I actually enjoy that kind of thing just as much as I enjoy making submissions. So if you're more inspired to play around with the data set and show things off that way instead of submitting to the competition, that's a great thing. Just a little warning, if you're using matplotlib in this, you might want to fork my script, which is called histogram of open closed by length. and then use this code for importing matplotlib at the top. There's something bizarre about our setup that requires a little bit of a strange import call. Is it on? Is it on? I think it's on. So the I talked to some people who were starting to move this direction with their features already. We want to use the text from a lot of the information here is in the text, right? And we want to. So one way to use text is to create sort of choose some words that are or might be in the text, and then for each of the rows, we can create a feature that says whether a word is in. Say if we're looking at the title, and we have 10 words like Python and Y, and then so is the word Python in the title is going to be one. It could be one of our features, right? Is the word Y in the title? It could be one of our features. So we have some tools in Scikit-Learn that make that a fairly automated process. This thing called the count vectorizer in Scikit-Learn feature extraction. So this is one of many nice helper functions in Scikit-Learn for turning things into feature matrices, right? So Scikit-Learn wants to have a matrix, but we might start with data that's not a matrix. So we need these helper functions to make things into matrices to feed into the models. So the count vectorizer is going to look at a bunch of text and choose some words for us. We can say that 200 is the most words we want to make indicator functions. Indicator columns that count how many times does that word appear in the text. And so we can do that to the train, we can do that to the test, and then we'll have a bunch of new features. So I'm calling this bow for bag of words. And if we call fit transform, this is I think I should have done this in 2 steps. I'm sorry. There's actually 2 steps happening here, fit and transform. So fit is what looks at the text and says, it looks at the text for every row in the data frame we feed it, or the column we feed it, and says, what are the words we're going to use? And then transform is what uses the words it's chosen to use to create a matrix. So then what we have is this matrix of indicators. Now, if we're trying to put together a feature set, then I really like data frames, right? So data frames you've got a column name, it's clear what your columns are. I want to turn this matrix, I know we're going to eventually have to turn it back into a matrix or array for Scikit-Learn, but for kind of keeping track of things and doing visualization, I'm going to want to put this into a pandas data frame. So if we ask the vectorizer, let's look at the vocabulary you learned and say, what are the words? We can look at what words we learned. And then what I'm going to do is create a list of column names based on those words that it learned. So title memory, title inside, title type. And then we can create a pandas data frame based on that matrix. And so if we were to just create the pandas data frame without saying what columns we wanted, we'd get some automatically named meaningless columns. But if we feed in the columns, we get some nicer column names. So now we have a bigger feature matrix. We can, what I did when I said index is I would say I want to use the mytrain.index. Whatever the index is we're using on mytrain is going to be the index for this new data frame. And that's what lets us join to make mytrain expanded from mytrain and our bag of words features. So then we could, for example, look at the word without. Most of the time that doesn't appear at all. I guess in the little sample I'm seeing, there's no questions where the word without appears in the title. But if we look at a histogram, there are a few places where that word appears. And if we focus on, so it's pretty hard to see what's going on in this histogram when almost all of the questions don't have any, don't have the word without appearing at all. If we only use the histogram for bins in the range from 1 to 6, we're cutting out the 0, and we see that there's a little more open closed questions. So 1 means open, 0 means closed. There's a few more closed questions that use the word without. Is the kind of thing we could do based on this sort of analysis of the data. So maybe you can tell a story about why maybe people who post questions that say, I want to do something without doing X, are saying, I don't know, I want to get, that's likely to be an indicator that actually they're trying to do something that doesn't, they shouldn't be asking for. I want to, yeah. So then when we do this kind of thing, we're going to want to do it to the training set and to the test set. So what I have here is a little function that we can use to do that same expansion that I just did on the train set, but also do it on the test set, and then return the new training set, the new test set, and also the column names that we added. So we can apply that by saying my train expanded, my test expanded, and the new columns are the result of using that function expand. And now we have a bigger test set, a bigger train set, and we can use the same function get score to kind of validate locally on our own machine and see how well that works by feeding in our list of new columns with a logistic regression model. So I don't know how it'll do on the leaderboard, but that gets me a score of 0.63 locally, which is a lot better than my last score from Notebook 2. Maybe if you want to play around with these sorts of features using the functions in 3.py and the 3.ipynb notebook, or actually, so is it maybe I'll there's one more kind of set of ideas and techniques we wanted to talk through before the end. So is it better if we do that now and then give you a long chunk of time to work? Or is it better if we work and then do that a little later? Christine? Would it be all right to do your content now if that's what people prefer? Or would we wait? Hands up for waiting. Hands up for doing it now. Is that all right, Kristen? Cool. Yeah.
Okay, so to wrap up, like I wanted to give like an overview of what we're doing. Like we've been talking a lot about small, tricks and things, and maybe there's a lot of information. Maybe at the end it's good to like step back and see what we're actually trying to accomplish here. How all these like small, tricks and preparation steps fit in the general purpose of doing data science, and give like a final final thoughts of like how people are improving their models when doing competitions. And there's like this very nice visualization that that I like a lot, that's called data science patterns, and kinds of like sums up this like what's your cycle when doing data science. And as we've seen, like an important part is doing all the feature preparation, how you extract data, how you with this make the discretization, how we select features, and that's like the last part we've talked about, right? Like we have this data set that has has some fixed columns that were already given, but then there's a lot of text, and from that text we could also make new extractions, right? So that part is we can see here, what do you do when you want to do feature extraction, right? Maybe we want to discreticize some of the variables. Maybe we just like, if we have a lot of variables, that might generate also a lot of noise, which might be something we don't want. So then there's also models of selecting those features that are actually relevant. And then also there's a part of like this pre-processing of, well, if those features don't exist for all of your rows, how can you, what's the different ways you can impute these missing values? Then there's all the part of the different models that exist, right? And we have neural networks, decision trees, we've seen some random forest, SVMs, all the different, and each of them has like their own like code, like small description, logistic regression, whatever K-means. So once you've tried all of these different models, and you have like get a sense of like how well your data set is performing, etc. Then it comes the time that you want to optimize, right? You want to start saying, oh, from all these models that I have, which ones are performing well, which ones are not, how I can combine them to get better accuracy, better scoring in my machine learning. And that's and I can do that in a various ways, right? Combining different models, having voting systems with ensemble methods, making sure that I'm not overfitting my data set by having like this tests that we've extracted from our training set. And then there's all the part of analyzing your results and validating your results to make sure you're not doing that, right? And that involves maybe just holding out, like what we've done before, hold out a part of your training set as your test set and using that test data as your evaluation. There's cross-validation methods that does that, like splitting your data set multiple times and getting the average of how well you're doing. You also might want to like take a look of the confusion metrics, so you can get a sense of, oh, what am I doing wrong? Am I doing wrong? Am I classifying wrong one type? Am I just like saying that, or another of the classes, right? What class am I not classifying properly? Maybe that gives me some sense of how I can improve my model. Or raw words, right? So this is like a very nice summarization of like this cycle. And in this last section of improving model performance, I just wanted to go a couple of some things. And the first one is like, it really comes down when you've seen people doing machine learning competitions of extracting better features, like having features that are actually relevant in that data set really turns out to be what makes one of like a person succeed. So we've seen before, like we've extracted some bag of features, and we can see like this simple performance very fast. It's saying if I just like used 2 of my last features, plus so like just using this like very simple logistic regression model, if I add all these new columns, how my model can change, right? So adding new features always helps, but you have to be careful in making sure that that score actually is the score that you have in your test set and not in your training, because adding features always improves your training score, because it might be because you're overfitting to your particular test set. So I also wanted to go through like Scikit-Learn also, uh, in this text extraction, you might want to use like some stop words and see, oh, I'm pretty sure that there's several stop words that are not going to have an impact. So I just like don't want to take them into consideration, but because that's just going to add noise to it. Then maybe I want to add more complex tokenization methods. Instead of just using the bag of words, maybe I want to use n-grams. And then you can also try and start using n-grams. Or sometimes you just like care about nouns, right? And there's the entity recognition of just grabbing nouns of your text. Some other times you might want to use lemmatization of saying words with the same stem should be considered just counted once. So all these different types of tokenizing can affect your end model. So testing all of those different variables in modeling can guide you. Another part, yeah. Yeah, I was just like finishing them. Yeah, I'll push the changes. I think it is the number 4 is it's just like I've added some more code snippets. Another section is how we optimize these parameters, right? We've seen that you have a lot of options. Like for each model, you can split training and test differently. Each model has its own parameters that you have to pass in. There's different ways you can tokenize and extract text. Although just like keeps getting like a huge, tree of what you can do and what's the end result, right? You want to have a way of automating that and being able to like search through all those different paths that you could have taken and finding what's the optimal, what's the best thing you could have done, right? And that's where grid search in Scikit-Learn can help you. This is a very simple example of I can have different C parameters in a logistic regression, and I can just pass this parameter grid to grid search, and it would just return me the different results. And we can see here that this parameter in this particular logistic regression does not have an impact because I get the same score. But it could have an impact, and you can have a different. Here you can find the. It's here. You can have multiple parameters and have all the grid and find what's the best. Here. And it's pretty nice explaining the tutorial of Scikit-Learn how to do grid search and cross-validate the parameters to help you find what's the best combination that you could find that helps your model. Another option for improving, as we said, is using different techniques of ensemble methods. And random forest is one, but you could also create your own and have multiple models and create your own voting system. Let's say you create an SVD, a logistic regression, something else, and you average. You can either do weighted average and see, what the majority of your classifier says, um, and choose that one as the result you're gonna give. Um, yeah, and then we can see how we can get with all these new features in a random forest to 0.59. Let's see who's winning the competition so far. What the and where's here? We have a 0.53. You wanna comment how what you're doing, so maybe you can help guide people the right direction.
Sure, sure. I was working on just building features like number of tags and age of account at time of submission. So that, and then I was just using that with logistic regression, and that moved me up a little bit. And then I just abandoned that and just now tried knife days just on the title text. And so that submission is like uses no other features other than knife days on the title text.
Cool. So we now know the benchmark.
Is that
So
just a bag of words on the title text?
Yeah, yeah, using all the features.
And now you base from Scikit-Learn?
Knife days from Scikit-Learn, yeah, using literally just that approach. So I didn't add in any of the other features prior to that.
cool. Anyone else that's under 0.60 the
Is it worth including in our submissions or not?
sorry?
The outputting the submission code is in this example file twice, but once it has index set to false, and I'm not sure which one we're supposed to use for.
Index set to false is good.
Okay.
Any other questions? Well, we have some time now to try to beat the benchmark to get the winner prize of the tutorial. Um, yeah.
So I think it will probably,
I'm curious about number 2, 3, and 4.
Yeah.
What are the other approaches?
only if you're willing to share. If you want to keep your, follow Kevin, right? Or follow
Yes.
Kevin's example and share, or keep your technique secret and try to beat him. What was,
Oh, no, sorry. I was looking at some very
oh yeah, I'll be right there. Yeah, I think we'll probably finish the competition at noon, and then the tutorial's over at 12:20. That'll give us a few minutes to see who the winner is, and maybe get the winner to try to talk a little more about what they've done, award prizes,